Okay then, 3, 2, 1. We're back in the room. Welcome back to another week of lessons with Mr. D. We're going to do some maths, as you can see. And today, I thought that we would start looking at something a bit new that you should have some knowledge of. This topic here, fractions. Dum dum dum. Some people dread this word when it comes to maths, but it's really nothing complicated or difficult. It's like all things, you've got practice, and there's a few things that you need to get your head around, but I believe that all of you will be absolutely fine, even learning this at home. So yeah, still working with the software, the programs, so bear with me if things go wrong, but we'll get into it. Before we start the main activity, we'll throw up a bit of arithmetic. Here's a few questions, you don't have to do them all, but just to get your brains thinking. Solve the number bonds. We have 39, add something equals 100. You're making 100 in all of them. It's just a bit of quick fire maths. Throw this back on for you. So when I'm doing these, let's take this one for example. 39, add something equals 100. Now, there's a couple of ways you can solve these types of problems. You can learn them off by heart. Quite a lot of sums to learn off by heart. A few strategies you can use. So for me, you can count on from the number you've got and then stop when you get to the number you need. The number that we need is 100, and we have 39. So I can count up in ones, but I haven't got enough fingers to know what the total is. So what I do first is make the next 10. Okay, so I've got 39. So let's do it on smart. I've got 39. I've got to add something and it equals 100. Okay, so think of it as a number line. There's my starting place at 39, and I've got to get to 100. Now I can count in little ones, but it'll take me far too long to do that. So we can think of it in jumps. So my first jump will be to the next 10. The next 10 is 40. I've got 39. The next 10 is 40. Now how much do I have to add to get to 40? 39. One more is 40. Then I can once I've got to 10, I can now do I can now count in tens really easily to get to 100. I've got 40, 50, 60, 70, 80, 90, 100. How many jumps is that? Add 10, add 10, add another 10. 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60. Add 60. And I've got my 1 over here, 61. Another good reason why it's good to make the nearest 10, because you'll probably be able to use your number bonds to 10 to help you see the patterns. So you'll know that 4 and 6, 4 and 6 make 10. So 40 and 60 make 100. That's why you work out the difference to get to the next 10. I've got to add 1 in this case to get to 40. And then I can use my number monster 10 to hopefully spot those patterns. Another way of solving these problems, 39 add something equals 100, is use your knowledge for inverse and know that, let's put it into a bit of a bar model for you. So my total here is 100, and I have one part of it, 39, and I want to know what this other bit is. So if I was to maybe take the 39 away from my whole, take the 39 part away from my 100, that would leave me with this other part here. So let's have a look and do that. Let's get my 100. And let's take away 39. Let's see if people can remember their subtraction skills. So 100 take away 39. 0 take away 9. I've got no ones. Tens, hundreds. I have 100 and no tens. 0 take away 9. Can I do nothing? No ones take away 9 ones. No, I can't. So we know that I'd go into the next column, my tens. So maybe rename some tens. But do I have any tens? Nope. So I'm going to have to go to my hundreds. Rename 100 to 10 tens. And cross that 100 out. So now I don't have any hundreds, but I have 10 tens. Can I still go back to my ones because I haven't finished yet? Can I do my ones yet? No, because I've still got no ones, so I'm going to have to rename one of my tens. Cross it out there. So now I've got 9 tens, and 1, 2, 3, 4, 6, 7, 8, 9, 10 ones. So now I can do 10 take away 9. 2, 3, 4, 5, 6, 7, 8, 9, and I have 1 left over. I go to my tens, 9 tens take away 3 tens, take away another 3, 1, 2, 3, and I will have 6 tens. 1, 2, 3, 4, 5, 6, and no hundreds, 61. So there's 2 different ways that you can go about it: number line method, or use your inverse and start with your total and take away the part that you have, and that will give you what's remaining. That's called finding the difference. Again, pause these, have another go. Just don't do them all. Just something to get your brain into gear. Super. Now, back to where we were. We were going to look at fractions, weren't we? There's a few things that we need to think about when we're looking at fractions. And we're going to go through those first. So when we're looking at fractions, it's really, really important that the 2 things we need to really think about is parts and your whole. Your whole is your most important thing when we're looking at fractions. Once you realise what the whole is, whether that be a cake, whether that be a class, whether that be a number, find out what the whole that you're working with, identify that, then all the fraction is just a part of that whole. And you can have fractions of anything. Hopefully these couple of slides will just help you see what I mean by parts of wholes. So let's take this slide here, for example. So the car, you can see on your screen here the car, and then I've got this wheel. So how can I look at those two things and think of them as a fraction? Well, I've got this sentence here: take something as a whole, something is a part of the whole. So take the car as a whole. The car, the whole car, that's my whole. Take the car as a whole. The wheel is part of the car, part of my whole. So that part is your fraction of your whole, the car. Take the lamp as your whole. The bulb is a part of the lamp, a part of the whole. You do this one then. So take the United Kingdom as your whole, and what's a part of the whole? Leeds is a part of the whole. So that's kind of to help you break some barriers. It doesn't have, fractions don't have to just be maths. You will have probably seen them in lots of different things like circles and cakes and pizzas, but you can, a fraction is just a part of your whole. A fraction is a part of the whole, and the whole is everything. Have a look at it in this slide, something a bit more familiar. So the whole is the circle. The red bit is a part of my whole. This bar here, take the bar as the whole. The blue bit is all, and then I've covered the red bit, that's a part of the whole. Whole and parts. Fractions are just parts of the whole. Again, we've got these birds. There's loads of different ways you can see these fractions. Okay, because it doesn't have to just be one. Your whole doesn't have to be one thing. Your whole could be a group of things. Okay, so all the birds here, flying and in the pond, they could be my whole. I've got how many birds? 1, 2, 3, 4 swans in the pond, and 3, just focus on the big birds, not the little ones, 3 birds flying. So I could have 4 and 3, 4, 5, 6, 7. 7 birds on the whole. The flying birds could be a part of that whole. The birds that are flying, that's 3 out of my 7. Or I could just maybe take the birds that are in the pond as my whole. So I've got 4 birds, 4 swans as my whole, and the black swan is one part of my whole. Over here we've got the whole, the red circle is the whole, and the cut out bit as a part, the blue bar of the whole, and a section of it would be a part. So that's if your whole is just one object, but your whole can be a group of objects as well. I've got the group of birds as my whole, and a part of it could just be the birds that are swimming, or the other part being the birds that are flying. Think of it as the class 3D, 3E. Your class could be a whole. Year 2, Year 3, Year 4, they're your wholes. And the children in that class, they're the parts. So if we've got everybody coming to school in the classroom, if we do a full register check and everybody is here, we have the whole. If only some of us are here, then we have part of that whole. Kind of makes sense? Just wholes and parts. That's all you've got to think about when we're thinking about fractions. What is the whole? And the fraction is the part of that whole. But as long as you always go back and you have a solid idea of what the whole is, and the whole can be anything, the whole can be a number, the whole can be a pizza, the whole can be a class. In this case, the whole could be a country, the country China, and all those different parts of of China, all those different cities and states, they're your parts. Let's carry on. England can be a part. England can only be the whole, it cannot be the part. Is that true? Can England only be the whole? Can we? England can be the whole and the part. Who are we going to agree with? Alyssa or Poppy? Well, England can be the whole and all the different countries could be the parts, couldn't it? So you could have England as a whole, then we could have Scotland, Wales, the United Kingdom as our parts. Or can England be a part of the whole? Well, think about the world. The world could be our whole, and all different countries could be the parts. Parts and wholes. So can we look at these pictures? Don't worry about what the fractions might be. Can we see there in these pictures? Can you find the whole? Well, the whole in this case is the bar, and the shaded bit is my part. In number 2, what's the whole? The half is the whole, the shaded bit is my part. How many parts do I have in question 1? 1, 2, 3 parts. Number 3, my whole is the circle, and I've split it into 1, 2, 3, 4, 5, 6, 7, 8 parts, and I've shaded one of my parts there, wholes and parts. 6 parts here. The whole is the hexagon. Right, another question for you. Think about a birthday party. Apparently it's Dylan's birthday party. And Dylan is going to get a cake that's going to be divided into 2 equal parts. This is the cake here, the circle. What am I going to do to divide it into 2 equal parts? That's another word to get your head around. So we're looking at fractions. We're looking at equal parts. So number 2 over here. Number 2, we haven't cut it into equal parts. 3, 1 and 4 are all equal parts. So this circle into 2 equal parts. Down the middle is probably a good shout. And I've got 1, 2 equal parts. Some of you might know that that is also called a half. We'll look at this in a moment, but that's how we would write, that's how we would show that we split our whole into 2 equal parts. We divided 1 cake into 2 equal parts. Each part is 1 half of the cake. Each part is a half. This is a half, and that is a half. The whole is the whole cake. Right then, let's get started. A bit of jargon that we need to always be careful with. So the fraction looks like this. The fraction, you will see, will have a number at the top, a line, and another number underneath, but these all have names. So the number at the top, this number here, is called the numerator. The line is the fraction, it's called the fraction line. Another way of thinking of this line is a divide. And the bottom number is called the denominator. The denominator shows you how many parts your whole has been split up into. So the bottom number here in this fraction of a half shows that I've split my whole, whatever it would be, into 2 equal parts. The numerator, the number at the top, shows me how many parts I want or how many parts I have. So maybe your first task is get a piece of paper, scrap piece of paper. Can you fold this into half? Can you make 2 equal parts with your paper? Have a go with that. So have a look at some misconceptions. I've folded it. Is this a half here? No, because my parts can't be equal. This part here would be bigger. I need 2 equal parts. Look at how many different ways I can fold it. Can I fold it in half like this? And when I fold it in half like that, can I shade one of those parts? So hopefully you have folded it down here into a half. I would have shaded one. So once I split it into 2, that's my denominator, and I've shaded one of those parts. I can fold it another way, like this. Is this also a half here? A rough line. Are they 2 equal parts? Yes, I fold it in half, and I've shaded one of my parts. Have a go at folding it this way. Have a go at folding it down here. And ask yourself, is that a half? If it is, why? If it isn't, why also? Then a little bit of a quiz question here. Which shape has been folded into a half? Which shaded part is half of the picture? Put a X if you think it's wrong. Or you can't do that on yours, but if it's A, B, and C, which one shows a half? Yes. B shows the correct half. Here, I have split it into, in A, I'm looking at A. Yes, I've split it into 2. But what's the problem here? These parts aren't equal, are they? They have to be equal parts. When you're looking at your parts, they have to be equal. What about C? Well, the parts are equal, but have I, what have I, and I've shaded one of those parts in, but have I split it into 2 equal parts, or have I split it into 1, 2, 3 equal parts? So that can't be a half. This one is my whole. It's been split into 2, and I've shaded one of those parts. That is a half. Making sense so far? Hopefully this should all be recap. So then you can have a look at these shapes here. What fraction would you call these shapes? Fill in the brackets to show what the fraction represents of the shaded part. So the first one here, the circle. Right, so I've got my whole as the circle, and what's the denominator? What's the bottom number? How many parts have I split my whole into? 3 parts, and I'm shaded one of those parts. Have we go at number 2, this one here. What's the whole? The whole is the rectangle. What's my denominator? How many parts have I split it into? And I've shaded one of those parts. Bottom one, the flower kind of shape. What's the denominator? What have I split it into? This is the whole. How many parts do I have? How many little ovals do I have? Yeah, so don't get confused with this one. This is not your whole here. That's a group, it's a group. All 4 of those petals or ovals would be your whole, and I've split it into 4. And I've shaded one of those parts. And here I've split it into 5, and I have shaded one of those parts. Do the same for A and for B in this question 3 over here. A would kind of look like this as well. What have I? This is my whole. My piece of paper is the whole. How many parts do I have? And I've shaded one of those parts. You should have wrote a quarter. And if you're feeling daring, maybe have a look at these and see if you can do a little bit of a challenge. Use the fraction. Can you express these pictures as a fraction? So it looks complicated, but have a think of what is your whole. Like the circle's my whole, the square is my whole. How many equal parts do I have? Now the trick here is I've split these shapes into multiple equal parts. But think about the shaded bit, or think about maybe if I help you with the square. Yes, there are multiple parts that they split into, but what if I did this? Forget the black line. What if I split it that way? That might help you think. Parts. So yeah, it's one. I'll leave that there for now. Super. So I'm going to leave it there for that lesson, and I'm going to attach a sheet that asks you to shade in some parts of the whole, just to check your understanding. So I'll upload the video and I'll send you another worksheet to upload. And you can draw these into your books or just write the answers in or work from the screen, so don't worry about printing them out. And I want you to check if you can show me different parts of the whole. Okay, hopefully that's a bit of an introduction. Think about the whole, think about the parts. Practice that sentence. Take something as the whole. Take your house as the whole. What is a part of that whole? You could take a cake as your whole, and a slice of that cake is a part. Wholes and parts, that's all we're going to do for today. Look out for the worksheet, and I'll see you next time. Goodbye.